This is Euclid Book 10, proposition number 103. And it says, a straight line commensurable in length with an apotome is an apotome and the same in order. Let AB be an apotome. That's this one right here. Let CD be commensurable in length with AB. This is going to be commensurable with this. I say that CD is also an apotome and in the same order as AB. Okay. For since AB is an apotome, which we've already established, let BE be annexed to it. We're going to annex this to this. Therefore, AE and EB are rational straight lines commensurable in square only. Okay. This is a rational straight line. This is a rational straight line. They're only commensurable in square. And this is by Euclid Book 10, proposition number 73. Let it be contrived that the ratio of BE to DF, as BE is to DF, that's what they're saying there, is the same as the ratio of AB to CD. As this is to this, so is this is to that. That's by Euclid Book 6, proposition number 12. Therefore also, as one is to one, so are all to all. This is by Euclid Book 5, proposition number 12. Therefore also, as the whole AE, which is this right across here, is to the whole CF, which is this right across here, so is AB to CD. So in other words, as this is to this, so is this is to this. But AB is commensurable in length with CD. These two lines are commensurable. Therefore, AE is also commensurable with CF. This whole line here is commensurable with this. And BE is commensurable with this. That's by Euclid Book 10, proposition number 11. And AE and EB are rational straight lines commensurable in square only. Okay? This line and this line are commensurable only in square. Therefore, this line and this line are only commensurable in square. That's by Euclid Book 10, proposition number 13. Now since, as AE is to CF, as this is to this, so is BE to DF. So in other words, they're going to say, as this is to this, so is this is to that. Alternately, therefore, as AE is to EB, as this is to this, so is CF to FD. Okay, so what they're going to say here is, as this is to this, so is this is to that. Okay. That's by Euclid Book 5, proposition number 16. And the square on AE, which is this, is greater than the square on EB, which is this, either by the square on a straight line commensurable with AE, or by the square on a straight line incommensurable with it. If the square on AE, which is this, is greater than the square on EB, which is this, by the square on a straight line commensurable with AE, the square on CF, which is this, is going to be greater than the square on FD, which is this, by the square on a straight line commensurable with CF, which is by Euclid Book 10, proposition number 14. And if AE, which is this line right across here, and if AE is commensurable in length with the rational straight line set out, CF, which is this right across here, will also be commensurable in length with the rational straight line set out. That's by Euclid Book 10, proposition number 12. And the same situation is true. We can say now that BE, which is this, we can say that BE is commensurable in length with the rational straight line set out. We can also say that DF is commensurable in length with the rational straight line set out. And if neither of the straight lines AE or EB, well, if neither this nor this, then neither the straight lines CF or FD. That's by Euclid Book 10, proposition number 13. But if the square on AE, which is this, is greater than the square on EB, which is this, by the square on a straight line incommensurable with AE, then the square on CF, which is this, will also be greater than the square on this. Okay, so if this is greater than this by a straight line incommensurable with this, okay, then also this will be greater than this by a straight line which is incommensurable with that. Alright, that's by Euclid Book 10, proposition number 14. And if AE, line AE, is commensurable in length with the rational straight line set out, CF will also be commensurable in length with the rational straight line. Okay, let me try that again. And CF will also be commensurable in length with the rational straight line set out. If BE is commensurable in length with the rational straight line set out, then DF will also be commensurable in length with the rational straight line set out. This is by Euclid Book 10, proposition number 12. And if neither of the straight lines AE and BE are commensurable in length with the rational straight line set out, then neither the straight line CF or FD will be commensurable in length with the rational straight line set out. Therefore, CD is an apotome and in the same order with AB. And that's the whole proof. I will tell you more in a future video. Stay tuned.